So let's talk about derivatives. Now this would be the derivative of a line. And notice that this derivative here looks exactly like calculating a slope. And that's all a derivative is. It's a rise over the run of some sort of tangent line. So for example, if you had a curve like this and you wanted to find the derivative where x equals 3, you go to where x equals 3 on your x-axis and you draw a tangent line to that point. The slope of this tangent line is going to be your derivative. So let's use an example of this. Let's say that you have a bucket and it's being filled with water, but it's not at a constant rate. That means that this water sometimes has a lot pouring in and other times it's very little being poured into the bucket. But what we could do is draw this curve which represents how much water is entering the bucket over time. Now, if you chose to take a derivative somewhere over here, so at one of these times, what you would find is that your derivative value is very large. That's because there's a very steep slope to this line, and that means a lot of water is entering the bucket at that time. But if you took a derivative at a sooner time where there's not much water entering, you would get a much smaller value for your derivative. And if this line was ever flat, that would mean that your derivative is equal to 0, which means you have no water entering the bucket at all because the water inside here is staying constant and isn't changing.